So, hi everyone, myself Vaku Jyotide, and today we are going to solve one beautiful question from LeetCode, that is question number 3373. We have already solved question number 3372, that is the brute force way of solving 3373. This one is a medium level question, and the question that we are going to solve now is a hard level question. Uh, the question may seem hard, but as soon as you will get the intuition of how to solve it, the approach how to solve it, and the approach I'm going to tell you is pretty straightforward and not pretty much confusing. So the coding will not too much difficult than this question. If you have done the coding part of this question, 3373 will be pretty much easy for you. So let's first check that what is the question itself, because understanding the question is very much important. Once you have understood the question, half of your problem is already solved. So let me read the question first. Solved it, but I have forgot it. So maximum, what it says that undirected trains target edges from path u to v is even. Is from path u to v is even. So I am going to explain the question with the help of an example, because example is pretty much important. This is tree 1 and 0, 1, 4, 5, 6, 2, 7 and 3. This is tree 2. So our approach will be pretty much similar that what we have done in the previous question 3372. So what the question tells? The question tells that return me an array that contains all the indexes of nodes of tree 1, 0, 1, 2, 3, 4. So for 0, count the number of target nodes. What are target nodes? The nodes that are connected with this node, and the number of edges encountered in the path of the target node should be even here. Understand? Mark this question even. In previous question, it is k. The number of edges should be k, but in this question, the number of edges should be even. So if I talk about the 0th node, for coming from 0 to 0, can I count 0? From 0 to 0, I have encountered 0 edges, and 0 is a even number. As I have I have encountered 0 edges, so I can count this. 1 edge no, 1 edge no, 2 edge yes, 2 edge yes. So for 0, from tree 1, I am going to get 1, 2, 3. 3 even nodes, 3 even targets. And if I connect it like the previous question, we need to find the golden node from tree 2. As we are finding the golden node from tree 2, how can we find it here? Suppose from 0, we are connecting an imaginary edge to the 0 of tree 2 from 0 of tree 1. As you have connected, so now we need to calculate how many number of nodes are present in tree 2 that have even number of edges from 0. So let's think that as it has even number of edges from one node of tree 1. So if we need to cancel this edge, then basically if we need to cancel this edge, then basically we need to do a simple thing that we need to count the number of target nodes present in tree 2 from the node that you have connected with tree 1, but the edges encountered should be odd for tree to mark the one odd. So how you are going to find the golden node in tree 2? For finding the golden node in tree 2, in previous question we have done k minus 1 edges. Now we are going to do odd edges, because from in the question it is given even and one nodes, and even minus 1 is odd, right? So as this edge will be considered, this edge has already been considered, so we are doing minus 1 and we are getting odd. Let's remove this. So now again do DFS or BFS in tree 2 and find how many number of odd nodes are present, from how many number of odd targets are given in each and every. In this one it is 1 2 3. No, this will not be considered. 3, this will not be considered. This 1 2 3 4, 1 2 3 4 5. For 0 it will be 5. Like this you need to calculate for each and every node and you will get the golden node. So if I will talk about the time complexity, you need to traverse each and every node in T1. That will be coming out as n if T1 has n nodes and T2 has m nodes. And for each node, you are going to calculate how many even targets are present in T1. So again n square, right? And pretty much it. And m square will be taken to find the golden node, to find the maximum number of targets in the maximum number of targets from T2. So m square plus n square, which one is greater? Now if we will check with the constants given, the constants given is now m is 10 to the power 5. So 10 to the power 5 square is 10 to the power 10. But we know that to solve a question, to avoid TLE, time limit exceeded, we need to do it within 10 to the power 8 operations. So this approach will not be passed here, or this approach will be failed here, because we are doing it in 10 to the power 10 operations. So now I need to think of a different approach, and to introduce you to the different approach, first of all forget about this question and learn this simple concept. Learn this very much simple concept, that is, take this graph. Zero, 1, 2, 3, 4. Okay. So take a pair. I am considering a pair of odd and even number of target nodes for each and every node of this tree. It has no connection with the question, but once you will understand this concept, the question will be very much easy for you. and we will not get TLE, time limit exceeded. So we are taking a pair of odd and even, odd number of targets. So for this one, how many odd number of target nodes are there? 1, 2. How many even number of target nodes are there? 1, 2, 3. For this one, how many odd number of target nodes are there? 1, 2, 3. How many even number of target nodes are there? 1, 2. How many odd number of target nodes are there for node 2? Odd 1, 2, 3, odd, and 1, 2, 2 even. And for this one, 1, 2, 2 odd, and 1, this is odd, 2, 3, 3 even. And for this one, 1 even, odd, even, odd, odd, even, odd. So even, even, even. 2 odd and 3 even. So one beautiful pattern you can observe from this one, that if there are 2 odds and 3 even target nodes for node 0, then for its neighbor the pair will get reversed. For here it is 2, 3, for here it is 3, 2, its neighbor. 2, 3, its neighbor will be 3, 2. 3, 2, its neighbor will be 2, 3. 3, 2, its neighbor will be 2, 3. So you have got a very good observation that you don't need to calculate how many number of what I can say, how many number of odd and even nodes are there. How many number of odds and even nodes are there? You don't need to calculate by BFS each and every time. This is an amoeba or alien. Okay, you don't need to do it again and again. So let's do it once and you can use it forever. And now if we'll approach the question will be pretty easy. I'm not going to number it again because I have drawn the trees for many number of times. Where it will be like this, and it's pretty much done. For this one, what will be? Okay, now when you are going to calculate the number of the maximum number of odd nodes, the golden node, then just calculate how many number of odd nodes or odd targets are connected with this. And once you have calculate how many number of odd targets are connected with this, then you can subtract the number of odd targets, number of nodes in tree 2 minus number of odd targets is equals to number of even targets, right? The left, if we subtract the odd targets, then we are only left with the even targets. So you can get the even targets as well. So how much time did it take? It takes and now if the odd value is t1 and the even value is t2, for this one it will be t2 comma t1, as you have already observed that it just got reversed for its neighbors. So for this one, the odd number of targets, it will be even number of targets here, and for even it will be odd. So you can just get the maximum of what we get in odd and even. Take the maximum and add it every time to this, and you are good to go. Why we are taking the maximum? Because you have already seen that m minimum limit is 2. M has to be 2. So for 2, if we got 2 and 3 as odd and even, then for this one it will be 3 and 2. So both of the odd number of nodes are there. So just take the maximum. If we take the maximum from here 3, although it is even number of targets for this node, but this is odd number of targets for its neighbor. So just take the maximum, and it costs you around m time complexity. So pretty much done in m time complexity. And for this one, just find like this one, t1 comma t2, odd and even. So once you have find for this node, when you are traversing, when you come to the neighbor of this, just take the odd count as its even count, and uh, add it in the array list, and add it in the array. So suppose, so if now we talk about the question, let me draw it beautifully. 0 1 2 3 4. This will be 0 1 2 3 4 2 3 4 5 6 7, right? Okay, so how many number of odd nodes are present here, odd targets are present here? Odd targets, right? So this is even, odd, 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 even, even, odd, odd. 1 2 3 4 5. 5 odd targets are present. How many even? 1 2 3 even. So if I take maximum of this, so 5, you need to add 5, because for this one it will be 3 comma 5, for this one it will be 5 comma 3, like this. So the maximum will be 5. And if for this one the number of odd targets is 1 2, number of even targets is 3. So as you have got the array 0 1 2 3 4, let's add odd, right? 1 2 odd, this is odd and this is even. So even is 3 plus, for finding it you need just for finding these two things you need just in time complexity, right? So in time complexity, and after finding it you are going to traverse, you are finding it once and you are going to traverse the whole array, that is n. So you are going to get this in a single time, that is big of n, 2 3. So even 3 plus what I have got here, 5 5 6 7 8. I'm going to get 8 here, right? 8. So I've got 8. In this one it got reverse, 3 comma 2, even is 2. So 2 plus 5 7. For this one 2 3, so it will be 3 2, or even is 2 plus 5, that is 7. For this one it will be for this one it will be 3, so it will be 2 comma 3, because this one will get reversed, odd and even. 3 plus 3 plus 5, that will be 5, 6, 7, 8, and for fourth one it will be 3, 2, 2, 3, odd, even is 3 plus 5, that will be 8. So for finding this, you are going to find, you need n time complexity for finding the golden node maximum, m time complexity, and you have find and store it once, then you are using it. So now you are going to traverse the whole tree one, so n, so just n plus m, and this is 10 to the power 5, which is lesser than 10 to the power 8. So you are good to go here, and the question is solved pretty easily.